We're going to do a quick trig review, and we're just going to start with basically a triangle here on the x and y axis. And if this is theta, okay, then this side that's over here, okay, that's my opposite side. This side that's touching it is my adjacent side, and the long line here is my hypotenuse, okay? So when I'm using sine, cosine, and tan, sine, cosine, tangent, all of theta, and you guys probably know SOHCAHTOA. What I'm talking about is opposite adjacent hypotenuse, okay? So sine theta equals, so sine theta O is opposite over hypotenuse. So as long as I know either the edges of my triangle, I can go back and find this angle theta, or if I know the hypotenuse and theta, I can find opposite and adjacent. So if I know adjacent and opposite, I can find hypotenuse and I can find theta, okay? If I know hypotenuse and I know theta, then I can find opposite and I can find adjacent, okay? We do this a lot in statics. Think about a truss of a roof, okay? Lots of angles, okay? What about a system of cables that are coming through that's decorative or whatever it is, structural? Again, these all are going to have X and Y components, and you have to be comfortable with this. So sine theta, sine is opposite, okay? So if this is 5 units long, and it could be 5 pounds, it could be 5 meters, it could be 5 inches, it doesn't matter. And I know that it is at 37 degrees, okay, my theta is 37 degrees, then I might be interested in knowing what are the X and Y components of that, okay? So the Y component, opposite, sine, so opposite. So we have to use sine. The X is adjacent, it's touching, adjacent. So this is cosine, okay? So if I'm looking at sine theta equals y over hypotenuse, then I can say that sine of 37 degrees equals y over 5, regardless of what the unit is. So y equals 5 sine 37, and we will get 37 sine 5 times, we get 3, okay? 3. If I want to find the length along this side, then I'm going to be looking at cosine theta equals x over hypotenuse, okay? Cosine of 37 equals x over 5. X equals 5 cosine 37, 37 cosine 5 times, and I get that x equals 4. Oops, you guys can't see that. Sorry about that. So if I were to actually sketch this out, x, I'm going to walk 4 units down the x, and then I'm going to walk up positive 1, 2, 3 units in the y, and that will show me where that vector is in space. Okay? Now, what you have to think about is I can describe the same vector, and let's call this phi. And I might have an angle coming off the y-axis. So you can't just memorize that the x component goes with cosine, the y component goes with sine. It doesn't, it's very dependent on where this is coming from. So if this is 5, okay, then I can say that phi equals 90 minus 37. So phi equals 53 degrees. Okay, I'll be walking the same. I'll be walking up and I'll be walking over. Okay, it gets to the same point, but instead of over and up, I'm walking up and over. That's why I'm using this phi. So now if I'm looking opposite, our opposite is x, is sine. So in this case, I'm going to have sine of 53 equals opposite the x component over hypotenuse of 5. So x equals 5 sine of 53. So let's work that out. 53 sine 5 times, and I get that x equals 4. Okay? So what I need to pay attention to is what axis that my theta or my phi or my beta or my alpha is coming off of. And I need to make sure I'm always opposite is the piece of the triangle that is not touching the angle that I'm looking at. So I can see that 5 sine 53 equals 5 cosine 37. They both give me the same x-axis. It's just from a different walking point, okay? If I were given this same triangle and I go up 3 then over 4, okay, how do I figure out what my angle theta is or what my hypotenuse is? So if I'm going up 3 and over 4, then I am looking at this angle, and this is my hypotenuse, and this is where we use Pythagorean theorem. The hypotenuse equals the x component squared plus the y component squared. So I have 3 squared plus 4 squared, 9 plus 16, 25, 5. My hypotenuse is 5. Okay. If I want to find the angle off the y-axis, which I know we called that phi over here, so let's call this phi again. Okay. Then I know my two sides, that's going to be my tangent. Okay. Tangent is TOA, opposite, adjacent. It's when I know my two legs. Okay. So tan phi equals opposite, adjacent. Tan phi equals opposite over adjacent. Phi equals inverse tan of 4 over 3. So we have 4 divided by 3, inverse tan this time, and I get that my phi is 53 degrees. Okay. If I wanted to know what theta was, here's theta. So I'm walking over 4, I'm walking up 3. It's the same point. I'm coming to the same point at the end of that vector. When I'm looking at theta, now the opposite is this y portion, okay? Tan theta equals opposite over adjacent. So I get 3 over 4. So theta equals the inverse tan of 3 over 4. 3 enter 4 divided by inverse tan. And I get a theta of 37 degrees. Now, how can I check to make sure I did this right? Well, 53 plus 37 does indeed equal 90 degrees. Okay, so I can check my work that way. You all need to be very comfortable with working with sine, cosine, tangent, and really understanding the opposite, the adjacent, and what the hypotenuse means.